Good morning, students. So today we're going to solve question 2 from GATE CSE 2022. The question states that the function y of x is defined in the interval 0 to 1 on the x-axis. This is the function that they're given us. Which one of the following is the area under the curve for the interval 0 to 1 on the x-axis, right? So first of all, for the area of the curve for y of x, right, we have been given this function, fine, but how do you visualize this, right? First, there has to be some kind of bare minimum visualization that we must possess, right? So there, if y of x is just some kind of curve over the this is basically your Cartesian plane, this is your y-axis and this is your x-axis, right? So from 0 till 1, the area under the curve, this is the area that we have to find, right? More or less, this is the question that has been imposed upon us, right? Imposed, basically you have to solve it now because you have to learn, so you have to solve. So now let's say, how would you understand it, right? So first of all, let's so that you understand that the function is comprehensive, right? The definition of the function is comprehensive is something that you must understand. If you have to find the area under the curve, then the function must be comprehensive. Why? Because if the function is of this sort, is broken from 0 to 1, right, the area is not bound, the area is not bound, right? It will become infinity. If then the area is not bound, it will become infinity, right? So area has to be bound, so this part must be continuous, this curve must be continuous from 0 to 1. That is a behavior that is implicitly assumed, and the function here also follows that, right? And how does it follow it? It follows it like this, right? If this is the interval for which the value is 3, so this interval coincides with the first one, right? It coincides with the first one, right, over here. And from 0 to 1 by 3, 1 by 3 is not included, but 1 by 3 is included in the second span from 1 by 3 to 3 by 4, right? Likewise, the third one is also like this, right? So pause the video and you can actually visualize and understand that from every point from 0 to 1, this function y of x is basically having a specific value. So this interval for definition is the domain of the function. For a domain of a function, basically it is a mathematical definition that for a domain of the function, every value of the domain has to have a corresponding value in the range. That is the definition of the function, right? So that is something which is present, and from 0 to 1 by 3, it is for the for 2, and from 1 by 3 included till 3 by 4 it is having value 3, and from 3 by 4 till 1 it is having value 1. That is the whole thing, and hence the curve is not broken, so the area under the curve is well defined and we can find it, right? So let's find it. I will give you two methods to find it. First is very simple and kind of direct actually. So basically draw the graph, right? Draw the graph and find it directly, because there are not too many values now, so we directly play with the values and then form rectangles, because these are basically going to have straight lines present, right? So from 0 to 1 by 3, you will have the value 2, right? And from 1 by 3 till 3 by 4, you will have the value 3. Okay, you will have the value 3. Okay, and from 3 by 4 till 1, you will have the value 1, like this, right? This is 1. So now you can actually find the area very easily, right? What is the area? The area is basically this rectangle plus this rectangle, basically this rectangle plus this rectangle plus this rectangle. Very simple, you can directly find it. Let's do that. So 2 times your 1 by 3, that is basically the first rectangle, plus your 3 times your 3 by 4 minus 1 by 3, plus 1 times your 1 minus 3 by 4, right? Let's simplify it further. You get what? 2 by 3 plus 3 times this is basically 9 minus 4, that is by 12, right? This gives you 4 and this gives you 5. I will simplify it further in the next step, and then this gives you 1 by 4, right? Which gives you what? 2 by 3 plus 5 by 4 plus 1 by 4, right? This thing becomes what? This thing becomes your 6 by 4, which basically becomes your 3 by 2. So what is the simplified fraction that we get? 2 by 3 plus 3 by 2, which is basically 6, and this is 4 plus 9, that is going to give you 13 by 6. Now, is any one of the options directly matching to this kind of fraction, because this fraction cannot be further simplified, right? So 13 by 6, yes, the third option is basically your answer for this question. Very simple question, and actually this is very simple question, and you must have been able to solve it, and this video only serves as a validation, right? But I will also give another method, because I have had more time to spend on this question than you do, so I will give you a better I think that this is a better method, right? So as you can observe, all three of them are basically constants, and this kind of pattern is basically from some value a to some value b, right? So you can direct, instead of analyzing it from a graph point of view, you can analyze it from a deduction point of view, right? So what is the deduction point of view? The pattern for every single entry is kind of like this. K, if this is k basically is a constant, a and x is from a till b. X is from a till b, right? So what is going to be the area under the curve for this, right? So if the function is a constant, so it is going to have a straight line, right? And a is here, b is here, right? So this is going to form a rectangle. We're considering one example thoroughly, but from that, whatever we get, we're going to deductively apply that on every single case, right? So what is the area of this rectangle that you're going to have? That area is going to be equal to, the area is basically equals to your k times b minus a. Is that not the case? Yes, that is the case, right? So directly apply this kind of formula to every single entry, and then just add them, right? The first entry gives you what? 2 times 1 by 3. The second entry gives you what? 3 times, basically 3 by 4 minus 1 by 3. This entry gives you what? 1 times 1 minus 3 by 4, right? And just adding them, you get the answer, and that is basically the same manipulation of numbers that we did over here. So you can do it again. I will not do that again, right? But when you do this kind of analysis, now you have you develop confidence in what you understand, right? So obviously you will ask me that sir, there is this inequality with equality, right? So these are inequalities, and these are inequality with equality present. So the constraint is of that sort, that this a is going to be less than or equal to b, right? So why is my analysis completely not taking into consideration these things, a difference between these kind of inequalities and these more hard inequalities, right? These are more soft because they also allow equality, right? So basically the point of why we are not dealing with that is, I will basically express that with a simple graph. So when you consider the area now, so a single point, the area contributed by a single point is basically 0. As you can clearly observe, it is not contributing any area, right? So these inequalities that are more soft contribute, also have an equal component to them, right? It has an equal component, but that equal component is providing a slit, a very slim contribution to the whole area, very slim contribution, and it is so slim, basically infinitesimally slim, right? Because this is calculus, right? Infinitesimally slim, so their contribution is negligible, so we can ignore them, right? And that is why I've ignored them while solving the question also, right? I do think that I have explained it well, but I do think that you must have understood it, and if you want to discuss more further on this, you can comment down. I will reply. I will try to reply. And with that, if you like the video, like and subscribe, and have a very good day.